Hello, everyone. We have fantastic Rob Richardson here on this call in this session. He will be presenting a database DevOps pipeline. And as we already mentioned a little bit, he's also an author of the book. I'm not sure, Rob, is only one in your career you've written, or maybe there's something I miss.
I've worked on a few.
Oh, yeah, that's great. Yeah.
Yeah.
So, yeah. Thank you very much for joining us today for this online event. And actually, let's kick off. So, Rob, over to you.
Excellent. Thanks for the introduction, Camille. We are going to build a database DevOps pipeline and compare and contrast this to regular pipelines, application pipelines. What's interesting is application pipelines can just delete and recreate the everything. With a database DevOps pipeline, we kind of can't do that. Users get a little grumpy when we delete the production database. Here's the part where I tell you I am definitely going to post the slides on my site tonight. But I've chased similar speakers and it hasn't worked out very well. So let's head off to robrich.org and we will see that the content is online right now. If you click on presentations here at robrich.org, you can grab a database DevOps pipeline. You can see the slides and the code up on GitHub. It is online right now. So while we're here at robrich.org, let's click on About Me and we'll see some of the things that I've done recently. Thanks for the introduction, Camille. I am a friend of Redgate, a Docker captain, a Microsoft MVP and MCT, and a Jetpack developer advocate. With Jetpack, I help people deploy to Kubernetes. So if you're struggling with containers in Kubernetes, I'd love to help. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp closer to you, hit me up on email or Twitter or find me here at the conference. And let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, SQL Source Control Basics, that was the one that we were referencing. That was a lot of fun. And I also worked on Pro Microservices in .NET 6. That's brand new, and both of them are available on Amazon. One of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. So let's talk about database DevOps pipelines. We talked about this guy. First, let's talk about, why do we do pipelines? What is a DevOps pipeline? The goals of DevOps are to create an automated, reliable, consistent pipeline that does the same process every time. Now, one of the things that's really cool is that a DevOps pipeline likely will lead to lesser costs for these concerns, because in the olden days, computers were more expensive than people, but now people are much more expensive than computers. So the more that we can get the computers to do the boring parts, the more we can have more consistent results and focus on the tasks that will really yield our business results. Pardon me. So our goal is to automate all the things. Automate all the things! And as we automate all the things, we'll get to a much more consistent experience, much more predictable deployments, and probably reduce our costs in deployment as well, because, well, computers are cheaper than people. Here's an example DevOps pipeline. You'll notice something interesting here. We start with a customer suggestion, and we end with customer feedback. If your DevOps pipeline doesn't start and end with customers, I would invite you to start to rethink this. Our goal is to deliver customer value. And so really, we want a DevOps pipeline that starts and ends with customers. In this case, we have a DevOps pipeline that starts with a customer suggestion. Maybe we'll put that in a task tracking system in Jira or Trello. And then when it comes time, a developer will grab the task, grab the code, and commit that code to a source control system. In time, the build server will notice that the source code changed, and it will build some content, run some automated tests on that, and ultimately deploy it to a pre-production server, in this case, a QA server. We may do some additional tests, maybe they're automated, maybe they're manual, and in time, then we'll deploy that content into production. At that point, we can get customer feedback, and given that customer feedback, we can start to make additional changes and updates to deliver more customer value. So that's a DevOps pipeline for applications. If we have a concern here in our DevOps pipeline, maybe we have a failing test, then we'll stop at that point and we'll use that feedback to restart our loop. So in this case, the automated test failed, and we can adjust our code to make those tests pass and thus deliver higher quality software. When we talk about shift left, it's this process of moving closer to the developer, closer to the beginning, because it's a lot cheaper to solve the request over here than it is to solve it way over here when we're deploying production content. And we need to redeploy the content, maybe inform users, maybe migrate production data. That can be kind of intense. So ideally, we're failing fast, as close to the beginning of the DevOps pipeline as possible. Now, we'll probably have this deployment pipeline. It will go off to a dashboard showing us the health of our services. And for applications, that is great. For databases, our DevOps pipeline probably looks like this. Hold on, everybody. I'm going to deploy to production now. Everybody log off. We're probably running these manual SQL scripts in production, and we're probably doing it late at night so that we don't interfere with users, which means we're tired, which means we make mistakes. With all that potential automation, with all the possibility of just-in-time deployments and continuous delivery, and yet with databases, the majority of the time, we're just opening up SQL Management Studio and firing scripts at our production server. I think we can do better. As we look at a DevOps pipeline for databases, we do notice some differences. Now, with a DevOps pipeline for applications, when we get ready to deploy, we can pave the server and install the new version. Or maybe we spin up a new container, and once the new container is started, we can kill off the old container. With a database, we have a stateful resource. And if we delete the production database, then that's not really going to help our users. We need to carefully maintain state. We need to care for our customers' data as we transition between these various states. So a typical DevOps pipeline for databases. We have a manual process. We connect to a remote server. We run some scripts. The scripts are of questionable origin. People just kept flinging them into a folder. And then now it's like, it's time to run them all. And the developer's tired. We're doing it late at night. Let's see if we can get more automated here. Yeah, this is a perfect landscape for making mistakes. And well, we're here at the critical piece, caring for customer data. That's not the time that we want to make mistakes. So databases are different. We do need to care for our customer data. We can't just pave the thing and reinstall the application. We need to preserve the data, and we need to very carefully transition it between states. We can't just stop and start over. We need to very carefully transition it from where it was to where it needs to be. Database pipelines. Now, the other thing that makes database pipelines different is they may be different between different environments. Now, in a production environment, we're updating production systems, and we have all of the latest hardware, and that's the premier system. We probably have a lot more data in production environments as well. In pre-production environments, we might have a database pipeline that migrates the schema to match our development platform, but we also have a database pipeline that gets database updates from production into non-production environments. And in particular, we have developer workstations. Let's double click into developer workstations and see how that works. A developer's workstation pipeline for applications is really simple. Git pull, build. We probably don't even think of that as a DevOps pipeline because it's just so natural and so simple. With databases, it's a little bit more. What if we have schema changes? Well, if we have schema changes, then I probably need to pull the latest from source control. I need to apply each of the scripts in the correct order to that database environment, and then fix up the data if necessary. So maybe my test data isn't quite the same as your test data, so the script may not exactly fit. Or maybe I was working on a different project that has some of the changes, but not all of them. So I have to carefully choose the portions of the SQL script that I'm going to run. Yeah, that's fragile. And that's only schema updates. If I'm looking for database data updates, I probably need to pester the DBA for a production backup. Hey, can you get me the database backup? And then wait. And then wait. Continue waiting. Pester the DBA. Hey, did you hear about my request? Can you wait some more? Eventually, the DBA is going to get me a database backup, which will be great. Now I need to restore it into place. And now that I have the data changes, now I'm back to the schema changes where I need to apply all the updates to get from productions version to my latest development version. And yeah, that's an intense developer DevOps pipeline. And we've got a developer who has quite a bit of skill in creating this process, and still it's really awkward. How are we doing at this automate all the thing part? So we're deploying when we're tired. We're trying to keep stuff up to date in non-production environments. We're spending a lot of time interrupting people. All else being equal, I think we're doing pretty bad so far. Let's see how we can build a database DevOps pipeline. The typical database process is manual. The database pipelines can't destroy and rebuild. So we need to think differently. Well, kind of. A lot of the steps that we'll do in a database DevOps process are similar. We'll just need to tweak them to fit this stateful process. So let's build a database DevOps pipeline. With an application DevOps pipeline, we probably have these 5 steps. Now, we may have some steps that are really dialed out, but I bet we'll have these 5. We'll get the latest content from source control. We'll version our assets. We'll probably bake the version number into interesting places so that we can get back to the source code that built it. Maybe we're just tacking on the date and time or the branch or build ID. Next, we're building, taking all of our source code, turning it into built assets, DLLs, executables. Then we'll test it. We'll run all of our unit tests, all of our integration tests, system tests, maybe performance tests. And here's where we can get really verbose and specific in all the different ways that we want to validate that our software is good enough. Once we've built and deployed it, versioned it, and gotten the latest, then we'll deploy it. Maybe we're deploying it to a pre-production server, or maybe we're deploying it to production. Now that 5-step process, get the latest, version assets, build, test, deploy. These are the steps that we'll do to build and deploy any software. And so what's interesting is these are exactly the steps that we will do when we get to a database. In particular, we want to do this on every code change automatically. So when we find a new version in our source control system, we'll get the latest, version the assets, build, test, deploy. Let's see if we can do the same in a database. Automatically on every change, we want to get the latest, we want to version our assets, we want to build, test, and deploy. Now, what's interesting here is, what does build mean in the context of a database? Well, probably what we need to do is restore a production database backup and migrate it to the latest version. How do we version our assets? Maybe we're updating a database version number or product version number in a SQL table. Or maybe we're adding additional metadata to it. Or maybe we don't roll back, and so the version is latest. Either way, we've got pretty much the same process. Now we can start to run tests. Maybe we're running integration tests from our application. And if everything works well, now we can throw away that test database and do that same process in our real database in production. So it's exactly the same. Automatically on every change, get the latest, version our assets by updating some columns explaining the latest version, build our content by restoring a production database backup and migrating its content into place, run our tests, and then deploy to production. The process is exactly the same. That's pretty cool. Let's take that knowledge and see if we can leverage it to build a database DevOps process. Now, the interesting thing with database migrations is we have some options. There's two major philosophies of thought here. We can do a state-based approach, or we can do a migration scripts approach. Now, we still kind of call it the migration process, whether we're using state-based or migration-based. So let's double click into each one and learn more about how they work. With creation scripts, a state-based approach, we probably have a folder for the various types of things, and each file is one particular asset. So we can see here on the right, we have a customer.sql. And if we pop open that thing, we have all of the columns and all of the data types for each piece of that table. Over time, these files will change and evolve, but we'll always have one file for each type of resource. That's excellent. Now, when it comes time to deploy these, we'll use an engine that is able to diff these scripts in a folder against the database version. If we're in a production environment, it will notice the changes in the folder and apply them to the production database. If we're in a development environment, we'll notice the changes in the folder and we'll apply it to our dev database. Or maybe we're working on our content, and so we'll go the other way. We'll take the changes that we made into our test database, we'll apply them to the scripts folder. Now, it does take a pretty intense database engine to be able to diff a folder full of scripts together with the schema in our database. But once we have that engine, we can do some really amazing things. By comparison, if we look at migration scripts, with migration scripts, we will have one file for each step in the process. In our first file, we may create all of the schema in our entire database. In the next file, maybe we're adding another table, maybe we're changing columns. We can see the exact process the developer went through to get from the beginning with no content at all to the end. Now, each one is a SQL file that might update a database schema, it might replace a stored procedure, it might change some data. Ultimately, the content of this file is everything that needs to happen in that step. With creation scripts, we had one file per schema item in the database, one per table. In migration scripts, we have one per step in the process that may include content from many tables. So the interesting thing with migration scripts is when it comes time to run it, we can just loop through this, this folder, identifying any scripts that we haven't run and run them. That's cool. Maybe we might have up and down migration scripts, one that puts the content in place and one that removes the content. We need a much simpler engine to do this. We just need to keep track of the scripts that we've run. And if we haven't run one yet, run it. That's cool. So how do we compare these? With creation script, we can run git blame or take a look at the file version history to be able to see how this table evolved. That's great. We can start with a blank database a lot easier because, well, if we have a blank database, we can just run all these create scripts. We avoid meandering through everything, every change. We take the straightest path from one point to the other to be able to deploy this content. So we may deploy faster with creation scripts. And we eliminate drift on each deployment. If the database has meandered away from us, we can run this diff engine, notice that change, that it isn't in compliance, and undo those changes. That's perfect. On the downside, we need a much more complex engine to be able to run this. So we need to be able to get that engine that can diff a folder and a database and be able to infer the distance between here and there. Because it's inferring the way to get from here to there, it may not be able to handle some of the more complex things. Let's imagine that we need to rename a column. Well, if we're inferring the distance between here and there, we're not going to be able to infer that that column was renamed. Instead, we're probably going to drop the existing column and create a brand new column, which loses the data. Or if we're splitting a column, splitting a table, or combining a table, we'll have difficulty inferring that path. By comparison, if we look at migration scripts run exactly the same every time. So if we've run it in one environment, it stands to reason that it'll work exactly the same in the other environments. It is a simpler deployment engine. We just need to know which scripts we haven't run and try running them. We can script anything, split the table, look up data, create a complex index. Anything that we need to do, we can script. It's not very engine specific. We just need files that can do stuff. On the downside, it's hard to find when an item changed. With creation scripts, we could just look at the file history. With migration scripts, we need to open up each one. Did it change in this file? Nope. Let's open up the next one. Did it change in this file? Trying to find when something happened is really difficult with migration scripts. We may just, well, decide that when it changed is not a question we can ask. Another downside to migration scripts is the deployment must meander. If we renamed the table and then renamed it again, and then renamed a column, added a column, then dropped it, all of the experiments that we do as developers to find the correct solution, the deployment in each environment must do that as well. And if we have significant amount of data in these tables, then we may have locks on these tables for a considerable amount of time as we meander through each of these changes, making the adjustments in order. And we must script all of the changes, even the simple ones. So if we're just creating a new table, we have to write that create script. If we're altering a table, we must write that alter script. We can't really infer any of the content because here in the migration strategy, we're describing the path of how to get from here to there, not the destination. So each of these don't have a whole lot of, each of these have some pretty significant downsides. With creation scripts, we can't infer the distance if it takes an interesting path. We must split a table or rename a column. So maybe we need mostly creation scripts, but a few migration scripts to be able to handle those larger cases. Similarly, with migration scripts, we can't know the history of content and we can't account for drift really easily. So if the production database gets a new index or renames a column, our migration scripts may not fit anymore. So we might need some creation scripts that allow us to be able to validate the end state that we're going for and validate that we're at the begin state before we begin. So what if we had a hybrid approach? Maybe we keep the migration scripts for the harder pieces and create scripts for the majority of content. Or maybe we have a few, maybe every time we run our migration scripts, we also capture the state. And so we're able to get that file history. Now, ultimately, the cool part with this hybrid approach is we can compensate for the downsides in each strategy. The bummer part about the hybrid approach, though, is, well, we need both engines. We need that really beefy comparison engine to do state-based pieces that can diff a folder with a database. And we need to keep track of the migrations that we've run and run them in order. So maybe a hybrid approach is great, or maybe it's the worst of both worlds. With a hybrid approach, it is the best of both worlds where we can compensate for the failures of both pieces. But we do need a very complex engine to be able to accomplish these calculations. It's great because we don't need to script the easy stuff, and we can script the more difficult stuff. But it might be difficult to know which order we need to run it in. Should we run the migrations first and then the create scripts? Or should we do the diff first and then run the migrations to clean up after it? With a hybrid approach, we can fall back to the migrations for the hard stuff, but what if the end state is different? What if this migration doesn't fit? Yeah, maybe the hybrid approach is perfect, or maybe it's just super complex. So which should you choose? Well, there's lots of tools that will allow you to do either the create script or the migration script, and you can ultimately choose the one that best fits your organization. I found that developers tend to focus on create scripts because that kind of fits the paradigm that they're using with source code. And I found that DBAs really like migration scripts because they know that that migration script has run on another environment. So it's more likely to succeed on this environment as well. Here's a list of tools that you may choose to use, both with creation scripts and migration scripts. As you grab these slides from robrich.org, you can click on each one to be able to learn more about the details of that particular tool. And you can also click down here to grab another list that's much more comprehensive of tools that you might enjoy. Some of the other considerations that you might use when choosing a tool. Some tools are very database specific. Now, it's great because you can dig deep into the bowels of that database and craft the exact SQL that you need to be able to do that. Some databases are more database agnostic. So perhaps they have a plugin provider. And so maybe they're missing some of the deeper details of the indexes, but they'll be able to support more types of databases. For example, very specific, Redgate SQL Compare and SQL Data Compare focus really deeply on working with the database at hand. But by comparison, Entity Framework has a provider model that allows it to work across lots of databases. So you might want to choose one that has either a higher fidelity fit for your database of choice if you focus in on one particular database, or if your organization focuses on many data stores, one that is more agnostic and that you can plug in more specific details to. We're back at the database build process. We have those 5 steps. Automatically on every change, we want to get the latest, we want to version our assets, we want to build, which means we'll restore a recent database backup, or maybe we'll create a new database, and then run the migration process, whether it's state-based or migration, and then we'll test it, probably running our integration test from our application. And if all of that works in our isolated environment, then we'll deploy it to our production environment. That's great. Now, whichever tool we choose to use in our build and test and deploy process, we can definitely use that. Is it state-based? Is it migration-based? Ultimately, I invite you to choose the tool that best suits your needs. But we will accomplish these 5 steps. Get the latest, version our assets, build, test, and deploy. And ideally, run that automatically on every change. So let's take a look at a database DevOps pipeline. We're going to look at both a state-based approach and a migrations-based approach. We'll also get to see a cloud-based or an on-prem based script, and also a GitHub Actions-based script, so a cloud-based script. Let's dig in. Now, the code that we'll see is up on GitHub. Here's the state-based one, and the migrations one is still kind of in flux. But we can see that we've got more content in here in the state-based approach than we would put in one. Here's our build.sh if we want to run from a batch file, build.sh, or build.ps1. Both of these are for local development. And then GitHub Workflows, this is the cloud-based one. Now, we would definitely not jam all these into one repository, but it's kind of nice to have all of the pieces here in one spot. We also have our application so that we can run our application integration tests into place. So let's start this off. Now, I'm going to start by running build.ps1. It does take a bit to start it off. So let's kick it off. And then let's take a look how it looks and come back to it. So here's build.ps1. Now, I'm going to very specifically set my SA password. I might choose to set that as environment variable before I begin, rather than just hard coding it here. Next, I'm going to do a Docker Compose up. Now, the Docker Compose up is going to create a test database on the fly. Now, the cool part is, in this case, we're instantiating SQL Server, but we could do this with MySQL or Postgres or Redis or any other data store. We just want a database. Now, I'm specifically creating a test database that is out of the way. We're not going to use one of the sacred databases here. We want to validate that our build will work in a throwaway environment. So let's spin up a SQL Server container. And once our SQL Server container is running, then we'll be able to do interesting things. Now, I'm specifically calling this network mode bridge so that I don't create another virtual network inside Docker Compose, and that way other containers can just reference it just by DB. Or I can hit it from my local machine just using localhost. Okay, so now that we've got our database spun up, and that's the part that we're waiting for here, by the way, let's take a look at the next step. Well, once we've got our Docker Compose up, we're going to wait for the database. I wish that there was a way to say, wait until it's ready, but short of pinging the database every second going, you ready yet? Then we'll just wait. Next, we're going to run a process to be able to create that test database. So in this case, I'm using the MS SQL tools container, and I'm just saying, hey, if the database does not exist, then create that database. Now that's perfect. I am creating a re-entrant script. So if I happen to have a volume for this database, then it will be there. Now, ideally, I'm restoring a production database backup rather than creating a whole new database. The beauty of restoring a production database backup is I can start from all of the wackiness that is production data. And I flexed my deployment process because I've started with production and migrated it into place. But in this case, I'll just start with an empty database and we'll be good. Next, I'm going to migrate my content into place. Now, I'm going to use Redgate SQL Compare and Redgate SQL Data Compare to do that, and I'll pass in these SQL scripts. Now, these SQL scripts are state-based scripts. So we can see that here's the, nope, that's the data. Here's the tables. We can see that it is a create script. As we alter the definition of the script, we will modify this one file. So this file will evolve over time. When we do the SQL compare, we will do all of the schema. That's our first command here. And then when we do our SQL data compare, we'll be able to push data into place. So for example, here in our settings table, we're going to set an API key, a build date, a git hash. Now that build date is really interesting. We'll use that to be able to version our assets as we go. Next, now that we've got that database in place, we've got all of our schema and all of our lookup data in place. Now let's go version our assets. I'm going to go get the current date, year, dash, month, dash, day. And I'm going to update that setting to be able to set it to today's build date. I'll also go grab the git hash of this particular database and set that in place as well. That's perfect. Now I know exactly when the database was built and what version of the source code it used to get there. Next, let's run our applications integration tests. Now, I'm going to select star from test status. That's a good, kind of hello world test, just validating that we've been able to migrate our content into place and that we have the values that we expect. Next, I'm going to run my database integration tests. Now we have our application here, and we have a suite under test. So I have a SQL helper, I have a repository, I have an entity framework context. And so here in our unit tests, that's not it. Suite under test. That's not it. Where did my test go? We'll run each of those tests. Where that source code was is escaping me at the moment. Once we've run all of our, we will actually inject our connection string into place by overriding this environment variable. And the beautiful thing is that our application will automatically pick it up. Here's our integration test. So our application will automatically pick it up based on grabbing these app settings. So once we've got these app settings, we'll run these integration tests. So, I'm just going to get everything from the repository, validate that it's not null. I'm going to get by ID for -1. So I definitely shouldn't return that one. I'll be able to run all of my integration tests and validate that my application works as expected. And then once I've validated this on the test database, then I'll Docker Compose down, and that instance of the database is gone. I spun up a test database. I ran all of these migrations. I validated that it would work. And now I throw that database away. If it doesn't work, I'm still going to throw the database away. And now that we've got that ready, now we can deploy it to our production database. So I'll do a similar thing, SQL compare, data compare, and version my assets. But I'll do this once I've already proven that it works. So let's see if we've got this. Oh, it looks like that didn't work. Docker compose down. Let's see if we can spin this back up. I suspect that while I was poking at it, we lost connection to the database. So let's do this again. Build.ps1. I ran this 5 minutes ago. It was fine 5 minutes ago, so we'll see. So we do need to wait for our database to spin up. I've seen it spin up in as quick as 20 seconds, but I've also seen it take more like 60 or 80 seconds. So we'll see if that's the case. If this doesn't work, then I'm pretty confident that I didn't wait long enough. And so I probably ought to flip over to a process that just pings it in a loop until the database is available. But we can see that we're going to go create that database, and then we'll be able to run this process against that temporary database running inside this container. I love that we can run SQL Server and other data stores in containers without having to worry about compromising one of our precious environments. Even our dev or test environment, if we have a migration that goes wrong, that could be pretty traumatic, and we would need to restore production database, production data to be able to get that to a known good state. So we're waiting for our database to start. The unfortunate part here is that it really is just guessing. Let's wait 80 seconds. Once we've got our database fired up, though, then we'll see it work a whole lot easier. Cool. Almost there. Almost there. Okay, so now we're creating our test database. Yep, now let's migrate our database to the current version. So we're running our SQL compare and also our data compare values. Let's see what schema we need to push in place. There we go. We say that we had to add these 3 tables. Similar thing when we're trying to migrate our data into place. What values do we need to do? Well, it looks like we need to pump 3 records into this table and 3 records into that table. Excellent. Now we're versioning our asset, so setting the git hash and the date. Select those to validate that we've got that content in place the way we expected. Now we're running our integration tests. And our integration test will inject that SQL connection string into place so that when it fires up that container, it's hitting that temporary database rather than a sacred data store. Once we're ready, now it says, hey, push key to deploy on server. Okay, I specifically coded this to say, hey, let's ask if the user wants to deploy. And in this case, I'm going to say no. But we did prove that concept of being able to spin up a temporary database and do the content that we needed. So let's take a look at how we might move that into the cloud. I'm going to start by flipping the script over to be a Linux bash script instead of a PowerShell script. Now, that's not completely necessary, but it does kind of help us move in that direction if we're moving to Linux. Now, the cool part is SQL Server works just fine with Linux containers. We're using Linux containers from PowerShell. So we're doing the exact same process. Let's spin up a temporary database, create that database if it doesn't exist, migrate the content, version the assets, run our application integration tests against that, and then clean it up. And in this case, we're just going to automatically deploy to our production database given these environment variables of where that production environment is. So that looks pretty simple. Next, let's flip this over to a GitHub Actions. Now, the cool part about GitHub Actions is that you can just run scripts. So, for example, I'm going to create the test database and run the migrations, and we can see that this process is, well, pretty similar. But let's make this a little bit more cloud native. So rather than having a durable database, we could choose to spin up a database with something like a GitHub Actions service. Now, GitHub Actions service is really interesting because we can spin up a data store temporarily during our build on the same agent. Now, in this case, it's a Postgres database. And I tried really hard to get a SQL Server database to run, and I completely failed. So let me show you Spawn, which is a really elegant mechanism for just spinning up just-in-time data stores. Now, Spawn has kind of a similar metaphor as containers. So I can create an image that might be last night's production database backup, and then I can create various instances from that image, so I don't need to reclone the entire database. So this is excellent. Let's use Spawn to be able to create this data store. So I'm going to start by checking out my source code. I'll spin up my image inside of Spawn, and it will output content that I need to be able to continue forward. Now, in this case, I'm using an empty SQL Server database, but we could definitely come from last night's backup instead. Next, I'm going to create a container, an instance of this database, and that will output various connection details that I can use going forward. So let's create a fake database in it. We'll use this script to do so. And so with this connection string and username and password, we can do all of these processes that we saw previously. Now we'll run our integration tests, and finally we'll deploy to our production database based on different environment variables that we'll store in our GitHub secrets. Now, this is not super GitHub Actions-y, but after we're done, we'll delete our container and delete our image, and that kind of cleans up our Spawn data store. So let's flip this over to only using containers inside of GitHub Actions. So here inside GitHub Actions, this is the very database-like thing. We're going to do it on the main branch, where in this interim one, did we do it? Yep, we did it on nothing, just so that we wouldn't have them compete. Now here, I'm focusing on using containers for most everything. So we'll use the Spawn container to spin up our Spawn data store. We'll spin up our Spawn container from that Spawn image. We just need to pass in our Spawn access token that I'll put in from secrets. We'll create our test database using the MS SQL tools container. That's really cool. And we'll pass in the outputs that we got from here for our data container host, our container port, the username, and the password. Next, I'm going to migrate the schema using Redgate SQL compares container. Also, Redgate SQL data compare, passing in the relative parameters. So my DB1 is the scripts folder, and my DB2 is that Spawn database. I'll do that for both my data and schema and data. And now I'm starting to version my assets. So let's update the thing to include the build date and the GitHub SHA. I am grabbing the current date only because I can't do bash scripts inside this args piece. So I'll just go grab the current date, and therefore I can use steps.date.outputs.date to be able to update that date. Now I'm going to run my integration tests from my application. I'll just do some quick SQL commands to validate it works, and then ultimately build and test my app, injecting that database connection string. If all of that succeeded, now in my temporary database, that's great. Now let's deploy it to our production database. So now instead of deploying to that Spawn database, I'm actually deploying it to the database that I have specified in these secrets. So SQL compare, data compare. Let's deploy our version details, so the current date and the SHA, and then ultimately we will delete our Spawn container and image, and we will specifically do this if always. If the build fails, we still want to delete our temporary database. Now, the cool thing about Spawn is it only lasts for as long as we specify, and up here I specified that it would only last 10 minutes. So at the end of 10 minutes, it's going to go away anyway. But for good code hygiene, I definitely want to delete it as soon as I'm ready. So let's try this out. Here in our repository, we can come in and right here, come into Actions, and let's kick off this workflow. Now here's our interim where we had much more just run the big script, but we're going to actually run the real one that will do stuff. Before I do so, here is my database inside of Azure. And if we refresh this, we can see that there are no tables inside that database right now. Okay, so let's do this state-based build. I'm going to run this workflow, and we'll get to watch this build. So we've got our new build in place. Excellent. Now it does, like it took a while to spin up our database locally, it will take a while for Spawn to be able to launch an empty database, but Spawn's pretty good about getting that database in place really quickly. Let's refresh and see if we've gotten our job. Yep. So we're pulling all of our containers and installing the content. That looks great. Now let's spawn the image. Oh, almost. It wants to, there we go. So now, now that we've pulled all of the images that we will use, let's get to spawn, and we're creating our data image. If we were restoring this from a production database backup, this might be a little simpler. Maybe we already have that image as part of an automated nightly job that once we finish backing up our database, we can restore it into Spawn to ensure that, well, our database backup succeeded, but also to make this creating a data image process faster. It does take a little bit to get this image into place, but once we've got that, we can continue on creating the data container, and the rest of that process goes pretty quickly. So once we've got this Spawn image created, we will create a data container, an instance of that image. In our case, it's an empty image, but now we've got a fake place to be able to play as we're validating our tests. Now we're doing the same process. Get the latest content, version our assets, build them in a neutral environment so that we don't impact any of our sacred environments, test it, and then if all of that works in the neutral environment, then we'll deploy to our real environment. So here's our temporary environment. We've got the data container spun up. And now we're creating the test database with the MS Tools thing. We'll migrate the schema. That looks excellent. So now we're running Redgate SQL Compare, passing in all of those environment variables that we needed to be able to get our content into place. In particular, mapping the volumes. So yep, we just needed to push these 3 tables into place. That worked well. We're now going to grab our data, and it looks like we'll push those 3 tables data into, or 2 tables data into place, our task status lookup and our settings. Now we're going to, here's the values that we've updated. So we know the build date is today and the git hash is right now. Now we're going to build our test application, application, and run our integration test there. So let's NuGet restore, and then we'll fire up our unit test. Now the interesting thing is the CMD here is actually our unit test rather than our production app. And that allows us to be able to inject that connection string into place. Looks like our unit tests have passed. So now we're going to go into our production database and deploy the content. So we didn't have any tables, so we'll put our 3 tables into place. Similar thing, we don't have any rows yet, so we'll put the 3 rows from each of our 2 tables into place. Once we've got that in place, now we're going to deploy our version details, the build date and the git hash, and push those into place. 2 rows affected. Excellent. Now we're going to delete our Spawn database, and our build succeeded. Excellent. So now that our build succeeded, let's come back to Azure Data Studio, and we will refresh this. We can see that we now have our 3 tables. If we were to open up our setting table, we can see that we've got our database versions. So we see here, we're selecting the data out of the setting table. That wasn't a difficult query. Am I going to need to do it this way? Select star from dbo.setting. Oh, that's just an empty document. That's not even connected to a database. Here we go. So we have our API key, which is just our development value. We have our build date set to today. We have our git hash set to the code that produced this. So now we know exactly what, when and what created our database. That's perfect. And all of that was pushed into place based on this GitHub Actions build. That was amazing. With this state-based approach, we were able to start from nothing and create this database. Well, how might we do this in a migrations-based approach? In migrations, we're going to look at Flyway. And Flyway is really elegant. Unlike SQL Compare, Data Compare that is very database specific, Flyway kind of has that plugin model. So you just specify a JDBC connection, and you can connect to all kinds of databases. So in this case, we've got migration scripts. So we'll start by creating that task status, the to-do table, the setting table, and we'll do all of that in one. So now that kind of creates all the schema. In our second migration, we're going to insert all the data into all the tables. So here's the setting table, here's the task status table, and we're just hammering this database with all of the details. For Flyway, we need to set the Flyway conf in the root directory. So we'll set our URL. Here's our SQL server. We may choose to override this based on passing in flags to our migrate command, but it's important that we don't check in our database password in the source control. So I've specifically commented this out. We may specify our database user, but even more so as we get closer to the cloud, we'll just inject cloud-based data here instead. So how do we run this? Well, I'll say Flyway migrate, and I'll pass in my SA password. Now in this case, I'm grabbing it from an environment variable. Now that's great. Flyway migrate will notice that we don't have any migrations run and run each of those scripts in place. Or if it notices that both of these pieces are already there, then it doesn't need to do anything. So how might we do this in GitHub Actions? Well, in a similar way that we did this with GitHub Actions for a state-based approach, we'll do this for a migrations-based approach as well. So we'll start with checking out our code. We'll create this content in Spawn. Spawn is amazing. So we'll create our image and our container, and then we'll create our test database. So based on the details that we got from Spawn, we will spin up a temporary database. This looks really similar to our other GitHub Actions build. Next, we'll migrate our test database. The Flyway action is perfect where we can inject the JDBC connection string and the user and the password that we got from Spawn, and that will get us into this data store. Next, let's get the current date, version our assets just by running the update commands on that Spawn database to get everything the way we expect. We'll run our integration tests. We saw that previously. And there's building and running our production application. And then we'll flip over to, now that we've got this working successfully, we'll flip over to deploying this to our production database server. The same process of running Flyway actions, deploying our versioned assets, so updating the date and the git hash, and then ultimately deleting the container and the data image from Spawn. Now, they will automatically delete in 10 minutes anyway, but it's nice to be able to clean them up as soon as we're done. So I don't have this GitHub Actions build running today, but I'm really excited to be able to show you both the state-based approach and the migrations-based approach. With a state-based approach, we have assets for each of our entities in our database. So here in our tables, we have one file for the settings table that will evolve over time. By comparison with the migrations-based approach, we have one migration script that accomplishes everything at that step. So maybe we created the to-do table, but we didn't have a create date or a task status. We might come in with a later migration that adds that. By comparison, if we were to do that in a state-based approach, we would just update this one file. So we got to compare and contrast both the state-based approach and the migrations-based approach. We got to compare and contrast how might we do this on-prem and how might we do this in the cloud. We also got to compare a very database-specific approach with a more database-agnostic approach, a provider model that may not have as high fidelity, but has support for much more data stores. And as we got into the cloud, Spawn allowed us to be able to create really elegant resources to be able to spin up our content in the cloud and not have to worry about how do we get another container with our data store. We always did this in a temporary spot, and if it worked in our temporary spot, then we would go to one of our regular databases, perhaps a development or production database. That way, if it didn't work, nothing's lost. We only throw away our test database. In our database DevOps process, we did those 5 steps, the same steps that we would do for an application. automatically on every change, we're going to get the latest code. We'll version our assets. In our case, we chose to update a table with our build date and our Git hash. We're going to build the content. Now that includes restoring a production database backup or creating a blank database, and then running the migrations process, whether state-based or migrations-based. We'll test it. We ran our application unit test. We also did some simple SQL queries to validate that our database works as expected. Now, all this is in a temporary environment. Once we know that works, we'll throw away our temporary database and we'll deploy it to the real database that we care about. We've validated that this process should work as expected, so we have a high confidence that this will deploy correctly into our real database. When we build a database DevOps process, we get to practice a production deployment every time. Whether we're doing a state-based or a migration-based approach, we're starting with a production database backup. So when it comes time for us to upgrade production, hey, we've been doing this exact process for the last few days or weeks on our pre-production environment, so we have high confidence that it will work in production as well. Part of starting with that production database backup is that we'll probably encounter all of the weird things that happen with data. How did you get a null in your first name? That's a non-nullable column. Or how did you get a last name that has so many characters in it? Or how do you have so many orders against one customer? The more that we can get that weird shaped data, the more that we can experience the interesting things in our pre-production environments. Will this lock the table for a really long time? Now we know, and we can compensate for that by perhaps altering our script or adjusting the time frame that we'll deploy this. I love being able to practice production deployments in non-production environments. Ultimately, we're creating automation, so hopefully we can sleep easier. We're no longer trying to run scripts of unknown origin while we're sleepy. Database DevOps. We definitely can get to a process of automation here with production databases in the same way that we can get to automation with applications. I would invite you to clone the repositories that you've seen today and take them out for a spin. If you're using SQL Server, then that's great. If you're using another database, then I'd love to definitely help. Hit me up on robrich.org or hit me up on Twitter at rob_rich. And let's definitely continue the conversation. You can grab the slides right now at robrich.org and the code. And for those of us here live in the event, what are your thoughts? What are your questions? What can I improve next time?
Great, fantastic. Thank you, Rob. And yeah, we are open for questions, so you can use the Q&A section or button to ask the questions.
One of the questions that I often get here is, so will this work with my database? Will it work with my database vendor or with my database type? Yes, I've been able to build DevOps pipelines for MySQL and SQL Server and Postgres. I've also built DevOps pipelines for Redis and Mongo. So yes, this can definitely apply to your database vendor too.
So Rob, maybe I have one question. So you presented how to build this CI/CD process in GitHub, actually, you know, but I believe you can do the same, exactly the same with Azure DevOps, right? With the pipelines in Azure DevOps. So in that way, what kind of things you need to change to adopt the code that you already presented? So how many things you need to change to make this YAML file be ready for Azure DevOps? How difficult the process is?
And you might also want to do this on TeamCity or Jenkins or GitLab. As we started migrating from this build.ps1 to the build.sh, then we moved over to this GitHub Actions build that more or less just, you know, ran the script. We would want to do similar types of behaviors, but moving to Azure DevOps' YAML or AppVeyor's YAML or CircleCI's YAML. And so at that point, we'd probably have a little bit different ways of kicking off the build, but ultimately the steps, the methodology involved is exactly the same. So yes, when I got very GitHub Actions-y, then maybe this wouldn't fit exactly into an Azure DevOps pipeline, but the methodology would. So maybe take this build database interim.yaml and convert that into an Azure DevOps build. That might be a smoother path. But to that end, yes, no matter whether you're using TeamCity or Jenkins, GitLab, or Bitbucket, you can still accomplish this same automation process.
Yeah, thank you very much. Yeah, so but there's some nuances, yeah, that you need to be care of and aware of,
Right.
you know, to make the whole pipelines working, you know.
Yeah. One of the things
yeah.
that Azure DevOps really likes to do is separate the build and deploy processes. And you could definitely do that here. If you wanted to separate the build and deploy processes, you might just do the build process with spawn. And then once you're done, then take those SQL files and flip them over into the release pipeline and deploy it there. Alternatively, the more we move closer to containers and cloud native things, deploy is a release is not really all that separate. So you may choose to just do all of the steps in your build pipeline instead of separating that build and release. If you flip over in Azure DevOps from the GUI-based builds to the YAML-based builds, then you've got that the build and release steps get combined as well.
Yeah.
You're right, though. There is nuance in the YAML.
Okay, there's no question from attendees, so I believe, yeah, guys, don't be shy. Of course, you can ask questions, or if you don't have any specific question right now, as Rob says, you can reach him out on Twitter, for example, or on his blog, I believe. So there will be like contact channels to Europe, yeah, and yeah,
Exactly.
you can reach him and ask any question now or later on, yeah.
And
yeah,
I always come away from these talks, you know, tomorrow, early next week, maybe even in an hour, and I'm like, oh. So definitely hit me up on Twitter or by email, and let's continue the conversation. I would love to understand more of your situation and how this might apply to you.
thank you very much, Rob. Great presentation. Fantastic flow, I would say.
Thank you.
Fantastic. Very technical. Very nice.
Excellent.
Thank you. So, guys, next session is in the next 27 minutes. So, yeah, hopefully we'll see you then.
Sounds
Thank you very
great.
much.
I'll see you in the next session, everyone.
Thank you.